Hello everyone and welcome to the last day of how to find integrals. We'll get to the application of integrals soon. So we're going to look at u-sub being a little more complicated than what we are used to. So if we look at the first example, what happens even if we don't have the 5x? What if I just rewrote it as tan cubed x secant squared x? Does that help? We look and we say, well, if this is just even x, the u can't be x. So what could this be? And again, if we forgot, we're looking for u and du. And we want to know what u is so that we can figure out what du can be and kind of take away that portion of it. So what is u going to be? Well, we look here and we say, we have a secant squared. What do we know that can give us secant squared? Or what do we know that can give us tan cubed? Or just tangent even. And we can say here that tan of 5x, the derivative of tangent 5x, is secant squared 5x times the derivative of the inside, which is 5. So 5 secant squared 5x dx. And now we just noticed here that this portion is taken right here. And so what we have left is just u cubed and a 1/5 out in front. So I can rewrite this as the integral, 1/5 of the integral would help. 1/5 the integral of u cubed, my fault, tan of 5x is this, so we can write u cubed du. And then we can go with this saying 1/5 times u to the 4th over 4 plus c. And we know what u is, so we're going to get 1/20th u tan 4 5x, so tan to the 4th 5x plus c. I'm done. So just like in the last one here, one of the things that you need to know is we knew that the derivative of tangent was secant squared, which helped us out here. If you don't know the integrals or the derivatives of trig functions, this is going to be extremely difficult. So just like over here, we know that the derivative of secant x is, or equals, it doesn't matter which one, secant x tan x. This is why I said it was important to memorize them. And if we look at this one, okay, we have secant, the derivative of secant x is secant x tan x. Well, notice that we have a tan x here. So the question is, and again, with a lot of this stuff, is how do we rewrite it? How can we see it? I can rewrite this as secant squared 2x, secant x, or secant 2x, tan 2x. And with this, notice that if I let u, I'll go up here, if I let u equal secant 2x, du is then going to be 2 secant 2x tan 2x dx. And notice that this right here, secant 2x tan 2x, is right there. And so all I have to do is say I put a 1/2 out in front to get rid of that 2, and I'm left with, so this is equal to 1/2 the integral of u squared, because that's where I got secant, that's a secant if you couldn't see that, secant squared, secant 2x, secant squared, du. And I know what this is, 1/2 u cubed over 3 plus c, which equals 1/6 secant 2x plus c. And do not forget the cubed, as I was about to with that. So 1/6 secant cubed 2x plus c. And the idea here is the fact that we are needing to rewrite this, and you're sitting there going, how am I supposed to see that? Hopefully with practice that helps, but not always. Sometimes you just got to rework things, try to work it out. If it doesn't work, try something new. But with this one, secant u gave us secant x tan x, and that's where we can get rid of this tan x. Let's look at another problem. So with this problem, I'm going to skip this one, we're going to come back to that one. With this problem right here, we're going to let you should see immediately what u should be, x minus 1. So du equals dx, which when we go to rewrite the integral, you'll notice that we're going to have the integral of x squared square root of u du. And this is an issue because we can't have an x squared and u's at the same time. So we realize that that's not going to work, but we have no other option. U has to be x minus 1. So what we are going to need to do instead here is we have to figure out how to get rid of this x. Well, one thing that we can notice here is that if we solve for x, x equals u plus 1. And if x equals u plus 1, in that integral we just had, we can now replace x with u's and get it all in terms of u, since that's what we need to do to have u substitution. So what we're going to do here is we're going to write the integral of x squared, which is u plus 1 squared, times u to the 1/2. I'm just going to rewrite it as that, du. And now we have an integral in terms of u. I can expand u plus 1 out, u squared plus 2u plus 1 times u to the 1/2 du. And I can now distribute the u to everything. U to the, we're going to add here, so 5/2 plus 2u to the 3/2 plus u to the 1/2. That's still the integral of that, can't forget this. And now, what we're going to need to do is actually take the integral. So we're going to get u to the 7/2 over 7/2 plus 2u to the 5/2 over 5/2 plus u to the 3/2 over 3/2 plus c. And we'll now know that we have to plug u back in. We said u was x minus 1. So now we'll get 2/7 x minus 1 to the 7/2 plus 4/5. 2 times 2 is 4. That's where I got that x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2 plus c. So you can pause it if you need to look at it. These are x minus 1s inside. One of the, before we move on to the back, I would like you just to try this. Don't spend too much time, but spend 1 or 2 minutes trying this, and then unpause it, and I'll show you what went wrong. And so with this problem, hopefully you said u to equal cosine x du equals sine x dx, and then you realize that, hey, wait, we still have a u and we have a x, and that's not going to work. So we're going to erase all this and start over. And so as I've said before, when it doesn't work out, what is something that we can do to try to rework the problem out, make it look something different, so that we can get u substitution to work? Well, only way we know how to rework cosine cubed x is maybe write it as we did above, as the integral of cosine squared x times cosine x dx. So we look at this and we can say, okay, u would still be u cosine x, du is sine x. We have the issue with sine x. And so what are we going to do? Well, if I need a sine x somewhere in here, where can that come from? And the key is right here. We need to remember that cosine x, cosine squared x, can be rewritten as 1 minus sine squared x times cosine x dx. That's using Pythagorean identity. Cosine squared x plus sine squared x equals 1. Move the sine squared x over, and that's what you get cosine to be. Now we should be able to say what u is. Well, in this case, we now have to state that u is sine x. Du is cosine x dx. Well, again, why is this nice? cosine x dx, cosine x dx. Those are there. And now we can take the integral of 1 minus u squared. So again, it's the idea of rewriting problems out, which is not intuitive to us. We don't like that necessarily. So we're going to have 1 minus u squared du. And we can now take the integral of this. U minus u cubed over 3 plus c. And we know what u is. U is sine x. So we can say this is sine x minus sine cubed x over 3 plus c. So this is another way just to look at it differently. But again, when you're given du to be a different trig function, we have to try to figure out a way to make sure that that other trig function is in the problem to begin with. And in this case, we thought u would be cosine, but instead it turned out to be sine. It worked out just fine. Okay? So that's the answer. These are integrals of trig functions. And the one thing that you have to realize is just you have to look at the type of problem and see, is it going to be sine, secant, or tan inverse. And this is just getting to know it. Watch me do a couple. We'll try some on our own, and hopefully we'll go over some more in class. So this first one here, we look at 1 squared and x squared. Well, that must be this one, where a equals 1 and u equals x. Notice that 1 squared is still 1, x squared is x squared. So we're good here. We're going to say then that that equals 1 over a, so 1 over 1. Oh, and, sorry, I forgot one thing here. That I need to still have du to be dx, because therefore I can replace the du there. So I now have, I can rewrite it in terms of a and u as the integral of du over a squared plus u squared. When I do that, I can now say what a is and u is. So 1 over 1, tan inverse of u, x, over 1, which is, or a, which is 1, plus c. So I can just rewrite that as tan inverse of x plus c. Why don't you guys try this one? So you need to realize that 2, if we have 2 and that equals a squared, how do you get rid of that? Well, you just square root it. So you're going to get square root of 2x, and so you should have this as your answer. The tricky part there was the square root of 2. With this one, notice that we are going to be, again, on sine inverse. We're going to let a equal 3 and u equal 2x. Now, here's the trick. du equals 2 dx. We don't have a 2 here, so I need to divide by 2 to get rid of that. This 1/2 is really going to come out in front. Now I can rewrite it as, let's see, u squared. So now the answer, the key here was just dividing by 2. I can get 1/2 sine inverse of 2x, over 3 plus c. If you look at this one, we get tan inverse. And so we're going to let a be 2, u to be e to the x. Why? Because if we know that u squared equals e to the x squared, we can rewrite that as e to the 2x. Now the difference here is if this really 2x needs to be up in front, our du really needs to be e to the x dx. Well, let's see if that makes sense. If u equals e to the x, du equals e to the x dx. And that worked out. So that is our du. So I can rewrite this now. Nothing to divide by. We had e to the x dx. So I can rewrite that now as 1 over a tan inverse of u over a plus c. So our final answer is going to be 1 over 2 tan inverse of e to the x over 2 plus c. And that is it for today. Don't worry about the last problem, and I will see you in class.